Welcome to another lesson video of the Liceo Math Club. Last week, the video covered the limit laws in evaluating limits of algebraic functions which are polynomial. In addition to that, this video will now focus on rational algebraic functions. To begin, let us redefine the meaning of the term limit. If f of x become arbitrarily close to a number L, as x approaches a from either side, then the limit of f of x as x approaches a is L. In simpler terms, this is the value that the function is slowly getting closer to. This is written as the example shown on the screen. Now, reviewing the limit theorems, or some consider it as limit laws, here are the 8 that were discussed. The limit of a function is itself. If the term beside the limit symbol is a number or a constant, then the limit is that same number. Next, the limit of x as x approaches c is equal to c. This is considered as the substitution law as well because x is just replaced by c. The constant multiple theorem states that the limit of a multiple of a function is that multiple of the limit of the function. The addition theorem states that the sum of a function is also the sum of their limits. And next, this multiplication theorem has a similar indication as the addition theorem. Two functions multiplied is like both of their limits are multiplied as well. For division, it is also the same, but now with the quotient and the denominator must not be equal to 0. For power theorem, the power of the function is also the power of the limit. And lastly, the root theorem states that if the nth root of the function is also the nth root of the limit, minding the fact that n must be positive. Now let us learn the meaning of a rational function. This function is in the form of a fraction where a polynomial is divided by another polynomial. However, the denominator must not be 0, so there lies the variation in ways to solve these types of problems. The form f of x over g of x, where the numerator and denominator are both individual polynomials, is an example of a rational function. Utilizing the laws or theorems that were discussed, let us now discover how to find the limits of these rational functions. Assume the following for the first example. The limit of f of x as x approaches c is 3/4. The limit of g of x as x approaches c is 12, and the limit of h as x approaches c is -3. Let the problem be the limit of the sum of g of x and h of x all over the f of x as x approaches c. For the first step, apply the addition law and turn these functions into individual limits. Now, using the division law, turn the f of x to another limit since they are similar as stated in the theorems. Lastly, use substitution law to replace the limit. Use the given at the top. 12 plus -3 is 9, and divided by 3/4, it is equal to 12. For the next example, we now have actual polynomials as our numerator and denominator. First, use the quotient law to turn the polynomials into limit form. Then apply the sum law and constant multiple law. As you can see, 2x squared is now 2 times the limit of x squared as x approaches 2. The rest of the terms are also changed. Next, apply the power law, where the power of the function is also the power of the limit. And then lastly, substitute 2 to all of the x variables since it is stated that the limits are found as x approaches 2. This now results to 1/4. For our last example, we will show an example on how to solve rational functions with square roots. Since the limit of the difference of the square root of x plus 2 and 1 all over x plus 1 as x approaches 1, -1, results to 0 when using substitution. Then, the conjugate of the numerator must be used. Conjugate is the same terms with a different sign. Multiply it to both the numerator and the denominator because doing so is technically just multiplying them by 1. Simplify the numerator but not the denominator since these would result to factors that would avoid making it 0. Now, cancel the x plus 1 on top and at the bottom, and the numerator would result to 1. Lastly, we use the substitution law to get the answer of 1/2. The club hopes that you have learned or have improved your knowledge on this topic in basic calculus. Feel free to message the Liceo Math Club Help Desk for your questions. Thanks for watching.